Hey everybody, how's it going? So in this video, what I'm going to be doing is going over two topics. I think I'll probably just like split the video in two, and one of them I'll be talking about dimensional homogeneity, and the other one I'll talk about resultant vectors, because I know we didn't talk about them as much or nearly as much as I wanted to in class. So I'll just go over two quick examples, one for each, and it will surely help you on the exam that you have this coming Tuesday. So let's go ahead and get started. So let me delete this. I worked it out like in the other layer and just had to make sure that everything was okay. So for this problem, I have an equation. It is called, well, it's basically called the drag equation. So it calculates a drag force based on certain parameters. How it goes is drag, which is a force, is equal to c sub d times rho times v squared times a divided by 2. So as you probably already know, what you need to do is you need to take what you're given as far as what variables you have for what units. So for example, here the problem is telling me that I need to find out what are the units? Well, yeah, what are the units for A? So I must be given all the units for everything else in order to find that out, because I have one equation, one unknown kind of thing. So C sub D is apparently unitless. Rho here, this like P looking thing, it is density, which has units of kilograms per meter cubed. V is in meters per second because it is velocity. A, I don't know. Drag, which we will just call D, is a force, which are in newtons and SI. Which are in kilograms times meters per second squared. So now I have all this information. I need to find out what A is. I can just replace these units in for the variables that I have here and solve for A. So let's go ahead and do that right here. So on the left side of my equation, I have kilograms times meters divided by second squared. Now the point of this example is, okay, well, what in the heck do I do with this 2 here? I think you might, or you should know what you need to do for this unitless C sub D, and that's replace it with 1. A nice looking one, not an ugly one. A little bit better. Let me go ahead and replace everything else. So kilograms per meter cubed, meters per second, A. And also, if you see a constant like this, you will always replace it with the same thing. You would always replace it as if it were unitless. So you would replace whatever you have there as a constant for just 1. And one thing that hopefully you caught, this squared here, I also need to include that. That is very important. Okay, so those are the 3 things that I wanted you to get out of this video. Replacing this one here, replacing this one here, and making sure you know how to distribute this square here. Because the way that you will distribute it is on the right side of your equation. After you start combining everything, you'll just end up with kilogram per meter cubed from this density. We'll ignore this one for now because 1 times anything is still just that anything. Meters per square, meters per second, I'm sorry. after distributing that square, you just end up with meters squared divided by seconds squared. That is really ugly, I'm sorry. And in the denominator, you have 1, but we can just like kind of ignore that. And on the other side, of course, you have okay, so my recommendation to you, I'm like speaking faster than I'm thinking. My recommendation to you is that you go ahead and just solve this problem, fast forward maybe to the end of the video, and then see if you got what I ended up with as far as units. If not, I'm going to go ahead and just solve this right now. So here I can immediately cancel out these two meters up here with the 3 that are in the denominator. So I can just like scratch out this 3. Let's go ahead and do this. So now we have 1. I can, whenever you have an equation like this and you see the same thing on both sides, as in the same thing on both sides, and you don't have like other terms like plus something, then what you can do, for example, this 1 over second squared, and this is still technically like 1 over second squared, you can just cancel them out. So for example, if I were to multiply the entire thing by second squared, it would cancel this second squared as well as this one on this side. So I would just be left with this turns into 1 over 1, which turns itself into 1, which turns that into, let me like write it out below. Times 1 times anything is anything, and we still have that A. So same thing, same rule applies with the kilograms, so I can cancel these out as well. And now all I'm left with is just A, well technically all I'm left with is A divided by M, A divided by M, and M on the other side. So I need to get this M to the other side here so I can get A by itself. Multiply everything by M. These two cancel out. Multiply it over here. And that leaves me with meter squared is equal to A. So this tells me that A is in units of meters squared. You might have already guessed that just because it's meter squared. So this is my answer. The main thing that I wanted you to get out of this video though is that you need to remember to square whatever units you have, and you need to remember to, or how to deal with unitless variables, if I tell you it's unitless, and constants. And you do the same thing for both of those by just replacing 1, and make sure, like I said, you know how to take care of the square here. So that's it for this example. I'll go ahead and start a new video for the resultant vector example, and if you need help on that one, you can just go ahead and watch that one too. So thanks for watching, and I will see you in the next video.